Okay, okay.
Yes, sir.
Okay. And SEM and TEM, the scanning electron microscope, it will not be transmitted through the workpiece. Okay, the electron which are falling onto the workpiece for the testing purpose, those will not be entering the workpiece. Instead, they'll be scanning this one. It is the electrons which will be bombarded over the workpiece will be reflected. The test piece, it will be reflected, and these electrons will be attracted by other thing. Okay, the bounce back, and these will be converted into required pixels of figure. So in the very high magnification factor, up to 10 lakhs and even more magnification. In your mobile, if you look into, if you go for 100 magnification, you cannot able to see the figure at all. It will be blurred. I think you can able to see that. Okay, this is a transmission electron microscope, and the SEM, it is a scanning electron microscope. And what kind of microscope it is? Is anyone can able to tell me? This one, the scanning electron microscope and transmission electron microscope we have studied. Which type of the microscope it is? Please tell me. Anyone? You can see that the specimen is kept in between, so definitely the electrons will be transmitting through this workpiece. So definitely it will be transmission electron microscope. So in a transmission electron microscope, electron gull will be there. Normally it is a tungsten wave, and at a threshold temperature, the electrons will be emitted and it will be attracted by the anode, and it will be made to flow in a very particular fashion by means of a condenser lens, and even magnetic detectors also will be there. And there will be a lot of lenses and intermediate lens and object lens. So many things will be there, and these will make the electrons to flow in a proper pattern and enter into the specimen. Okay, and after it is passing through the specimen, you can see that the fluorescent screen, on the fluorescent screen, the magnified image of the object, which will be containing the inner parts like nano materials and all these we can able to visualize. This will be, it will be in the order of 10 millions magnification. You cannot imagine 10 millions magnification. It is 1 million is 10 lakhs. Okay, thousand lakhs, thousand and thousand. Okay, so what the 1 into 10 to the power of 6 times, it is 1 million. And you can even more than that, 10, 20, 30 million times we can able to magnify them. This is how. And already I have shown you the transmission electron microscope, how it will be working. And this will be a kind of high voltage electron, the voltage electricity will be supplied to this anode, sorry, the cathode. And once the electrons are emitted from the barrier, and the cathode, it will be heated, and this will be having the CRT tube just like a TV, and this will be emitted, and this will be electromagnetic coil. The main function of the electromagnetic coil is it will be the divergent electron beam which will be converged, and it will made to flow in a systematic way. It will be deflected. And under electromagnetic coil, it is called secondary coil. It will be focusing the beam to a certain part. It will be deflecting towards the specimen. All these manually can be operated. Okay, those can be manually operated, and this is called as the copper grid. Okay, this is a copper grid, and other one, this is called the projector lens. This will be called as projector lens, and this will be image. And on this there will be a specimen will be kept, and we can see that the electrons which are falling onto this, we can able to visualize its image in terms of the millions of magnification. Okay, the image we can able to get this image, or even recent the transmission electron microscope, they can able to give you the printed output also. Okay, so the accuracy of these will be totally depend on the type of electron microscope you are going to select. And the working of the transmission electron microscope, there will be a tungsten filament. A tungsten filament will be there. It will be generating the beam of electrons, and this will be focused on the specimen by means of a condenser. These are the condenser, a set of condenser, and these condensers will be used to focus the light onto the specimen. And the next one is the magnetic lens. Okay, these magnetic lens, what they do, they'll be putting all these in a systematic way. Okay, while passing through all these, this will be a projector magnetic lens it is. So the projector magnetic lens main object of using this is how much magnification you require, you can able to set up this, so that the inverted image of this will be falling onto this. And next this will be called as the final image, and this final image can be is on the fluorescent screen it is, and even we can able to magnify still, and we can take the film output also. We can take the photographic film also by means of this. This is how the transmission electron microscope will be working. Okay, so we can able to find out very quite difference between the transmission electron microscope and the scanning electron microscope. The scanning electron microscope, the work surface will be scanned, the specimen will be scanned, so most possibly it will be kept at the end. And in the transmission electron microscope, the specimen will be kept in between, so that the electrons will be passing through. And in that case, the electrons will be reflecting back. So this is only the difference. Among these two, there will be at least one will be there for the final examination. You can see that. Now let me go through the advantages and limitations of this transmission electron microscope usage. Okay, and it is a more powerful and more potential, and you can see that even more than 1 million times it will be having a magnification factor. More than 1 million times the magnification factor we cannot imagine. Okay, so that we can able to study the inner details of the nano synthesized nano material, and even we can able to look at the bonds between the nanoparticles and the distance between the nanoparticles and the orientation of the nanoparticles. And now you know that very important thing, the nanoparticle alone, how it behaves, it will not behave in a group. That is what we need to understand, why this microscope will be very much useful. And it will be providing the information about the compound structure, as just now I told you. Even a single element and the compound structure also we can able to look at, and the images will be very high quality, and it will be giving you the detailed information about. And if the magnification factor or power is very less, what happens? A blurred structure will be formed, or we cannot able to identify what is there inside. So this is very powerful, and it can able to even give you the surface features and the shape and size, orientation of and the structure of the material inside subcomponents. And it will be another one thing, it will be easier to operate with a proper training. A person is going to operate it should have the proper training, so that once after proper training he can able to easily manage it. And what are the disadvantages of the transmission electron microscope? It will be very larger in size, and it will be expensive, more expensive, and everyone cannot keep the transmission electron microscope, and it is required a setup at laboratory. Okay, and it is a very difficult. And another one, the preparation of the specimen for the transmission electron microscope, it will be laborious. That means the initial preparation, it takes a lot of time, and more than that, what we require is artifact. It is totally depend what quality of output what we get, it will be artifact. That means the way by which we are going to prepare the sample. The sample preparation plays very important role. Okay, and another one, the very special training is required to prepare the specimen at the same time to operate the TEM. That is one of the disadvantages. Okay, and another one, almost all the materials, as I told you, it is possible to test them, but some of the materials it will be very some of the limitations should be there. The sample should be transparent enough, it can able to allow the electrons to pass through. Okay, and it can able to allow the electrons to transfer through them in the vacuum chamber, because it cannot be operated in the air, because once the air is colliding with the electrons, it will be changing its direction, and purpose of having this electron microscope will not be work out. So always it should be worked in a vacuum chamber, and the materials which can able to operate it, and it can able to allow the electrons to transfer through, and those materials can be used. This is one of the restriction. Okay. And it required definitely almost all the mechanisms and systems required a maintenance and special housing and all. It is, I don't say it is one of the disadvantages. All the equipments should be maintained and they have to be calibrated. And even the transmission electron microscope, it will be losing its accuracy by often and often using it. Okay, the accuracy may be due to the mechanical or electrical or electronics or the computer-based systems altogether, they are working together. So definitely the erroneous outputs, once it start to give, it has to be recalibrated frequently. That is one of the disadvantages. Okay. One important thing is we cannot able to see the images in different colored other than the gray levels. That means black and white. Gray levels we can able to see. Gray levels means the combination of white and black to different intensity which will be giving you, and this the reading of these nanostructure or some of the photofilm, only countable people are there, and reading I can able to read, someone people and can able to read, but the reading the inner details and giving the information and understanding the characteristics and understanding the orientation of all these, it requires a lot of training and experience of a person. Okay, this is one. And the TM application, let me come back once again. It will be other than our nanotechnology, it can be used in the medical, biological, material research, forensic analysis, the police departments, the fingerprints and all we can able to, and gemology, that is some stones, a very specific type of stones will be there to study the inner details of the stones like gems and all, we can able to use them, and in the industries, the metallurgical industries, and for the education purpose, these transmission electron microscopes can be used. And its low rate will be starting from 1.5 crores rupees. Okay, and it will be higher cost end. Okay, and it can able to even provide the morphological and compositional and crystalline informations and topological informations also. The morphological information, how the structures have been formed, what was the earlier structure, and what is the layer behind, all these we can able to find out. And if it is to be identified, we can able to even find out the composition, what composition it is having, and the crystalline structure and its orientation, and the topological, that means the outer cover study, all this can be done by using this transmission electron microscope. Okay, and even because it will allow the researchers to see the sample, view the samples of molecular level. Okay, and they can able to, or it is possible to analyze the structure and structures of the molecules. Okay, and another one, the study of the crystals and metals, all these can be even done at the industries also. Okay, even a very specific type of hardness and some case of hardening you require to do, or any kind of treatment you require to give. The material is very sophisticated to be used. That time we can able to visualize its the microstructural characters, and we can able to decide what kind and what level of hardness HRC is required. That also another one important thing. So for all these possible ways we can able to use, but for almost all the materials unnecessarily we cannot use them. It is a costlier process. Okay, so that, and it can be used for the manufacturing of the computers and silicon chips, semiconductor, the analysis and all these we can able to do. And the companies they are using for identifying the flaws and fracture and damages of micro sizes. Okay, all these and the durability, expected life and efficient product, all these can able to see or visualize through this TM. And these, as I told you just now, the colleges and universities, they are using for the study purpose to understand the molecular structures, molecular orientation and molecular bond. All these we can able to study them. And another one, the density, the composition. The main aspect of this is that any composite material we are going to make, for example, to increase the durability or hardness or yield strength, and for what we are going to make this composite, to study them, the monopathic layer also, that means whatever the layer, if you have selected a particular layer, that should be representative of the whole area, and we can able to see the dispersed particles, whether the dispersed particles are uniformly distributed or not. We can able to visualize them, so that we can able to even change the manufacturing process also. So this is one of the use of this the TM microscope. As I told you, it requires a very special type of training, and based on the requirement and based on the scientific the engineering requirements, some kind of softwares we are going to change them. Okay, the diffraction grating and the magnification power and the calculations and so many other inner calculations it has to do. For that, some softwares we are going to upgrade. What happens, the students, professors, industrialists and the users, all these have to be especially trained as and when it is required. Okay, and now today it has become very much useful for the person or people who they are going for the synthesis of nanoparticles, nanoparticle synthesis and nanoparticle production. And there, all these people, they have to basically keep these the TM. Okay, this is about the transmission electron microscope and scanning electron microscope. Okay, any doubts are there? You can ask me under this. Under this, any doubts are there? Let me know.